All right, let's talk about one of the trickiest parts of calculus, figuring out which convergence test to use for an infinite series. I know, it can feel like you're just lost in a sea of tests, but today, we're going to build a clear, step-by-step strategy to give you a solid path forward. So let's dive right in. I bet you've been there, right? You're staring at a problem and you've got like a dozen different convergence tests just swirling around in your head. It is a classic roadblock for sure. So the big question is, with all these options, where do you even start? So here's our game plan. We're going to build a 5-step decision tree together. Think of it as your roadmap from total confusion to the right answer. We'll start with why this is a problem in the first place, then get into your crucial first move, how to spot the really obvious patterns, when to pull out the more specialized tools, and then we'll wrap it all up in one final checklist. So first things first, you have to realize that picking a convergence test is not a random guess. It's actually all about pattern recognition. You got to think of yourself as a detective. Your job is to look for clues, little signals inside the series that point you to the exact right tool for the job. And you know, every good detective has a go-to first move. For series, this is the one test you should always try right at the start. Why? Because it has the power to solve the whole case instantly and save you a ton of work. And that first move is the divergence test. It is beautiful in its simplicity. All you have to do is take the limit of the terms of the series, the a sub n part, as n goes off to infinity. Now here's the golden rule. You have to remember this. If that limit you just calculated is anything other than 0, I don't care if it's 1 or 7 or infinity, the series diverges. That's it. You're done. Case closed. This one rule is the ultimate time saver. Okay, but what happens if the limit is 0? Well, that just means the test is inconclusive and our investigation has to continue. So let's move on to our next step, looking for the usual suspects. These are the most common and easiest types of series to spot. You're on the lookout for 2 special forms here. First up, the geometric series. That's where you have a constant ratio r raised to the n power. And second, the p series, which looks like 1 over n to some power p. The reason we look for these is simple. If your problem matches one of these patterns, you don't need a complicated test. There's a simple rule you can use to get your answer super fast. All right, so let's say you've done the divergence test, and it's not a clear-cut geometric or p-series. No problem. Now it's time to open up our specialist's toolkit. This is where we look for more specific clues to pick the right advanced tool for these trickier cases. The very first clue is a visual one. Just look at the series. I mean, literally look at it. Do you see an alternating part, something like a -1 raised to the end, or maybe n plus 1 power? That's the little engine that makes the terms flip back and forth between positive and negative. If the answer is yes, if you see that, your brain should immediately jump to one place, the alternating series test. This is your go-to tool for any series that flips its sign with every single term. It's a direct response to that visual clue. Now for 2 real powerhouses, the ratio test and the root test. These 2 really highlight that idea of pattern recognition. So, do you see factorials, that n with an exclamation mark? Or maybe constants raised to a power, like some number c to the n. Those are huge signals screaming, use the ratio test. But on the other hand, if you see the entire expression is being raised to the nth power, well, that is a giant signpost pointing you directly to the root test. We've got 2 other specialists in our kits. So what if your series looks, well, it almost looks like a p-series, but it's got some other stuff cluttering it up? That's the perfect time to use the comparison or limit comparison test. And finally, the integral test. This is your tool if you can look at the series terms and see a function that's continuous, positive, and decreasing, and most importantly, something you can actually integrate without a huge headache. All right, we've looked at all the individual tools and the clues that point you to them. Now, let's put it all together into one single clear checklist you can use on any series problem that gets thrown your way. Okay, the most important thing here is to follow this exact order, because it goes from the fastest checks to the most complicated ones. Step 1, always start with a divergence test. If the limit isn't 0, you're done. Step 2, look for those special forms. Is it geometric or is it a p-series? Step 3, see that alternating term? That's your cue for the alternating series test. Step 4, got factorials or constants to a power? Use the ratio test. Step 5, is the whole thing to the nth power? Use the root test. And finally, step 6, only if you're still stuck, only as a last resort do you think about the comparison or integral tests. Follow these steps and you'll always find the right path. And this really brings us right back to that main idea we started with. This whole process, it's not about trying to memorize 10 different tests by brute force. It's a skill. It's about training your eyes to see the patterns hidden inside the problem, and those patterns will tell you exactly which tool you need to grab. So there you have it. You've got the strategy, the complete decision tree from start to finish. You know the order to go in, you know the key patterns to look for. So the only question left is, which series are you going to go solve first?